ready for this? The big, big, big idea. Okay? Don't write this down, but we're going to try to help you understand exactly what it's doing. Okay. That look familiar? What's this coordinate? Right? And then this one right here, either the 30-degree angle, ends up being the root of 3 over 2 and 1 half, which is 0.866 and 0.5. So if we convert them to decimals, that's what it would be. And we didn't write them as decimals, did we? We wrote them as exact values. But today we're going to write them like that. This one was the root of 2 over 2. The root of 2 over 2 at a 45-degree angle, which is 0.7071 and 0.7071. Okay? And then this one right here, just switch the values. There's 1 half of the root of 3 over 2. So you add 0.5 and 0.866. Then what is this coordinate right here? 0, 1. And then it just kind of continues back down the other side, right? Only some of them turn negative, right? Now, do you remember, was sine the x value or the y value? Sine is the y value, correct? And how about cosine? Is cosine the x value or the y value? So cosine is x. And if you remember, this is pi, so this is pi over 2, this is 3 pi over 2, and this is 2 pi all the way around, right? So what I'm going to do is I'm going to take what we refer to as a unit circle, and I'm going to put it onto a graph. What is the smallest value of sine that you see on here? It's the smallest y value that you see. 0, right? If I went back over here, this coordinate is negative 1, 0. This coordinate is 0, negative 1. And it comes back to 1, 0. Now what is the smallest y value that you see? What is the largest y value that you see? So since sine is the y values, sine will have a largest value of positive 1 and a smallest value of negative 1. We're actually going to take sine of x and graph it as a function. We're going to see what it looks like. How much is once around the circle? 2 pi or 3/16. We're going to go in radians right now, and so we're going to count it as 2 pi. How many quadrants does it take for sine to be able to do one full revolution? 4 quadrants. So I'm going to take that 2 pi and divide it up into 4 parts. Pi over 2. So can you see parts of the unit circle right here? The 0, the 1, the negative 1, the pi over 2, the pi, the 3 pi over 2, the 2 pi. Okay, so it's all there right now. Now what we need to do is we need to plot some of those points, okay? For example, we'll start with the easy one, okay? Let's say I have a 0-degree angle. What is the y value of a 0-degree angle? 0. So that means that the sine of 0 is 0. Then I'm going to increase my angle. I'm going to look at an angle of pi over 6. I'll do pi over 4, and I'll do pi over 3. Okay? So it's hard to see those. I'm just going to kind of scribble them in there. But do you remember what the y value was at pi over 6? What's the y value at pi over 6? 1 half or 0.5, right? So at pi over 6, right here, and then this was pi over 4, and this was pi over 3. So the y values go 1 half or 0.5, and then 0.7, and then 0.8, and then 1. So that's what I'm just going to map out. So you said that the sine of pi over 6 was 1/2. The sine of pi over 4 was 0.7. Sine of pi over 3 was 0.86. And the sine of pi over 2 was 1. What do you think happens after we get to the top? It goes back down, right? I mean, if you look at the unit circle, it's going to go from 0 up to 1, and it's going to go from 1 back down to, and it's going to go from 0 to, and then from -1 back up to 0, right? So here's what happens. It goes all the way up to 1, and then at pi, it goes back down to 0. And 3 pi over 2 went all the way down to -1. And at 2 pi, it comes back up to 0. And so as I draw this is the kind of shape sine of x makes. How would you describe that shape? Like a wave, right? We're sitting by the ocean. Anybody see the ocean over break? Oh, I wish I could see the ocean. I don't remember the last time I saw the ocean. It's been a long time. Many, many years. But it's pretty cool. Sine wave, totally cool. And the reason why this is so neat is as my voice travels to your ears, sound travels as a wave. As light travels from our projector to the screen, light travels as a wave. So many things in the world travel in forms of waves. In fact, we could model an exact sine function that would show how my voice travels from my mouth to your ear. We could. What changes with sound? Pitch, volume, right? You can increase the volume by increasing how high it goes up and down. I mean, there's all sorts of ways that you can change the way that a wave looks. So it has great application. We'll get to the meat and bones of it. The maximum value is 1. The minimum value is -1. The amplitude, AMP, the amplitude is the distance that it goes above and below the axis of rotation, and that would be 1 unit. The period is how often it takes to repeat itself. It repeats itself every 2 pi. Cosine is extremely similar to sine. Okay? It's just a little bit different. Look at our values again. Cosine is the x value or the y value. X. What is the smallest x value you see up there? Even smaller? -1. What's the biggest value you see up there for x? 1. So therefore, cosine will also have values that go between +1 and -1. What is once around the circle? 2 pi. How many quadrants in once around the circle? So I divide it up into 4 parts. Let's look at our first value for cosine. At 0 degrees, or 0 radians, what is the x value? 1. At pi over 2, what's the x value? At pi, what's the x value? At 3 pi over 2, what's the x value? And at 2 pi, the x value? So I'm just going to plot those onto my grid, or onto my graph. You said the cosine at 0 was 1. At pi over 2, it was 0. At pi, it was -1. At 3 pi over 2, it was 0. And at 2 pi, it was back to 1. So you can see this graph. I pick it up and bring it right up here, pretty similar to my sine graph, isn't it? In fact, if I simply just move it over, it's the exact same graph. So the sine graph and the cosine graph are the same graphs. They're just shifted horizontally. They still have a max value of 1, a minimum value of -1. The amplitude is 1 unit. The period, it repeats itself every 2 pi. Those are the characteristics for your sine and cosine graph. We want to do 4 things with this. Eventually, we want to graph y equals -2 times the cosine of 3x minus pi over 6 plus 4. That looks pretty challenging, doesn't it? Today what we're going to do is we're not going to focus on the plus 4, and we're not going to focus on the minus pi over 6. We're simply going to focus on 2 transformations. And those transformations would be amplitude and period. How do we figure out the amplitude? The amplitude is quite simple. You look at that number in front, and you take the absolute value of it. The absolute value of A. That's the same thing with sine, and the same thing with cosine. The period is normally 2 pi. But what happens is if there's a value in front of the x, we divide 2 pi by that value. And that's the period. 2 pi divided by b. Everybody flip to the very back sheet in your notes. This is the sheet that you get to use on the test, and I will also give you this to use for your final exam. What you want to be able to do is you can see that these are the parent graphs. If you'd like to draw the x-axis and the y-axis a little bit better in there, a little bit darker, you can go ahead and do that. But I tell you right here, sine and cosine, the amplitude is the absolute value of A. The period is 2 pi divided by B. So those pieces are readily available for you, okay? So I give you that information. Let's practice some of these problems. Flip it on over. And we're going to skip through that because we just don't have time. We're going to go straight to the graphs. Example 4. We will identify the amplitude and the period for each one. Today we are just focusing on amplitude and period. Amplitude is the absolute value of the number in front of sine or cosine. For this one right here, y equals 3 cosine of x, what will the amplitude be? 3. Therefore, the graph will go 3 units above and 3 units below its axis of rotation. So all the graphs you look at today are going to rotate around the x-axis, or y equals 0. So it goes 3 units above and 3 units below. So that's the first thing you do is to mark those off. Can you do that? Not too tough, is it? What number is it? What number is in front of x? 1. So the period is 2 pi divided by 1, which is 2 pi. So I mark off 2 pi. After you mark off your period, you always divide it into how many parts? 4 parts. Why 4? Because there are 4 quadrants. Watch how I divide it. If you take 2 pi and divide it in half, what do you get? 1 pi. If you take 1 pi and divide it in half, what do you get? Pi over 2. Now, watch me count. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. Okay. So we count to come up with that third spot. Cosine. As you looked at the cosine graph, did the cosine start at the middle or did it start at the max or min? Where did cosine start? As we look back at our graphs that we created right here, it looks like sine started at the middle, whereas cosine started at the max. So sine will always start at the middle, and cosine will either start at the maximum value or the minimum value, one of the two. Okay? So because it's positive, we will start at the maximum value. So we start up here. And after that, we just cycle through the spots on the graph. So if cosine starts up here, is it going to then go up or is it going to go down? It's going to go down, and it will have to cross over the x-axis at the first spot. And as you move on to your next one, it will drop all the way down to -3. After it reaches its bottom, it will then go back up, and it must cross over the x-axis, and then we'll go to the top. There's your graph. On your assignment, do I have them printed off like this? Sorry, I made a mistake, but that's all right. We'll figure it out. Okay. All right, negative sine of x. Amplitude is the absolute value of the number in front. What's the number in front of sine? 1. So what's the absolute value of 1? 1. Or -1 is in front, so the absolute value of -1 is 1. So I mark off +1, I mark off -1. What's the number in front of x? So the period is 2 pi divided by 1, which is 2 pi. So once you get used to some of these numbers, it's sometimes easy to just continue writing down from previous problems. And remember, did sine start at the middle or did it start at the max or min? It starts at the middle, right? Now, what's different about this problem compared to the ones we've done so far? It's got a negative. When you see a negative in front of a graph, what does it make the graph do? Makes it do a vertical flip, right? So sine wants to start by going up, but because it's negative, it will do a vertical flip. It will therefore go down. After it reaches its bottom spot, what is it going to do then? It's going to go back up. Just cross over 0. And then it will go to a height of 1. And then it will come back down to 0. As you graph it, you can see that you have that reflected graph. It's upside down. Upside down. Not too bad, huh? Try a couple more. Okay. What will the amplitude be for the next one? 4. The period will be 2 pi divided by, what's the number in front of x? Pi. What's 2 pi divided by pi? Just 2. So the period is 2. And the amplitude is 4. So I marked off my 4, -4. Marked off 2 for the period. If I divide 2 in half, what do I get? 1. If I divide 1 in half, what do I get? 1/2 or 0.5. Now I'll count. 1/2, 2 halves, 3 halves, and 4 halves. Is this graph a sine graph or a cosine graph? So will it start at the max, min, or middle? Middle. Is it going to start by going up? It's going to start by going down. cycle through all these pieces. I'm tricky with the next one. What's the amplitude here? 2. How do I find the period? I take 2 pi. I divide it by, what's the number in front of x? Close. It's 1/3. You can rewrite x over 3 as 1/3 times x. Those are the same expressions. So therefore, the number in front of x is 1/3. So I have 2 pi divided by 1/3. Oh no, how do I divide by fractions? Multiply by the, so instead of dividing by 1/3, I'll multiply by 3 and I get 6 pi. So I'm going to mark off my amplitude, 2 and negative 2. 6 pi. 6 pi divided by 2? 3 pi. 3 pi divided by 2? 3 pi divided by 2 is the same thing as 3 pi divided by 1/2, right? So I'm just going to write that as 3 pi over 2. Let's count. 3 pi over 2. 6 pi over 2. 9 pi over 2. After 9 pi over 2 would be 12 pi over 2, or 6 pi. See that? We just count to find the next pi. Does cosine start at the middle or the max or min? It starts at the max or min. Cosine wants to start up at positive 2, but the negative sign will make it do a vertical reflection. So where is it going to start? We'll head up. Nice little picture. Not too bad, huh? Let me give you your worksheet, and we'll try a couple problems together. All right, let's try a couple challenging ones, huh? Let's try problem 6. All right, let's try 6. So, amplitude 4. The period be 2 pi, I'll write it over 1, divided by, what is the number in front of x? 2 pi over 3. 2 pi over 3 is the number in front of x. I will multiply by the, what happens? And I'm left with write it as a fraction. What's half of 3? If I take half of 3, I get 3 over 2. What's half of 3 over 2? 3 over 4. Let's count. 3 over 4. 6 over 4. 9 over 4. 12 over 4, right? We'll write the same ones on the back side, just negative. I know I didn't do this in the notes, but it shouldn't be any big deal. is cosine. Will cosine start at the max or min, or will it start at the middle? It'll start at the max in this situation because it's positive. And as I move to the right, we'll go up or down. Drop down over 0. We'll bottom out at -4. And it will move back up. So that's one full period. I want to show 2 full periods, so I'm going to draw to the back side as well. Where do you think it goes from here as I move to the left? Yep, down, and then all the way down the bottom, and then back up and up. Just want to kind of follow that pattern off to the negative side. That will help you grab that. Let's do one more. Flip it over. Which one do you want to do on the back side? You can choose it. Want to try 11? Okay, let's do it. What's the amplitude? Two over 5? The absolute value. The absolute value means we simply make it positive. We don't have to take the reciprocal. I'll just mark off 2/5. And the period will be 2 pi over 1 divided by, what's the number in front of x? 3 over 5. How do I do that? Multiply by the reciprocal, so 5 over 3. Does anything cancel? You get 10 pi over, okay, so I have to take half of 10 pi over 3. So that will make 5 pi over 3, right? So half is 5 pi over 3. What's half of 5 pi over 3? 5 pi over 6. And now let's count. 5 pi over 6. 10 pi over 6. 15 pi over 6. Can that be reduced? 15 over 6 reduces to 5 over 2. So 5 pi over 2. This is kind of weird, isn't it? 5 pi over 6, 5 pi over 3, 5 pi over 2, and then 10 pi over 3. But that's how you come up with it. We're going to do the same thing on the back side. This is sine. The sine starts at the max, the min, or the middle. Starts at the middle. Is it positive or negative? So will it go up or down? Go down. After I do the right side, I just follow the pattern to do the left side. As I go to the left, is it going to go up to 2/5 or down to -2/5? Up to the 2/5. It's got to kind of follow the pattern of the wave. So, identify amplitude, identify period, divide them up, and decide your starting point, and you should be good to go. Okay? So, this is good practice. I have the MCP all ready to go. You can see why I chose not to cover a lot of material in the notes because we are right at time right now. So, again, this is the last content that you're going to see for your final exam. I think you guys will do quite well. Do we'll have a couple work days this week. My guess is Wednesday and Thursday will be work days. What day is your final?